Hello, everyone. Thanks for joining the webinar. Today's topic about KubeArmor. That's one of the most popular cloud-native runtime security tools. My name is Yongkang He. As you can see from the screen, I love Kubernetes. I'm fully certified on Kubernetes. I'm a CNCF ambassador and a KubeArmor advocate. I love multi-cloud. I'm certified on top of 5 public cloud, and I'm also heavily involved to the multi-cloud community. So as you can see from the screen, I'm literally part of all different public cloud community. I'm a Microsoft MVP for just 2 months, and I'm a Google Cloud champion for 3 months now. And I'm also AWS community builders for 2 years, and plus Alibaba Cloud MVP for 3 years now. So join me to learn security, learn cloud, learn Kubernetes. So what is KubeArmor? KubeArmor, it's the open source project right now. It's a sandbox project of CNCF. It's a runtime protection tool for Kubernetes and other cloud workloads. KubeArmor provides an observability and policy enforcement system to restrict any unwanted malicious behavior of the cloud-native workloads at runtime. So a few weeks back, the team just submitted a proposal to move KubeArmor to the incubating stage. So for those of you who are not aware, so when the project accepted by CNCF, it will be initially a sandbox project. Then based on the maturity level, then it can be moved to the incubating stage and finally becomes a graduated project. So KubeArmor started about 2 years ago. And so far in the last 2 years has gained a lot of attractions from different organizations and the community. So the team believe KubeArmor is ready for incubation. So feel free to support KubeArmor. So what is KubeArmor? In a short, it's a runtime security enforcement tool. It's a security engine leveraging eBPF and LSM to secure your containers, your IoT and edge devices, your 5G networks. And it was created by Equinox and then donated to CNCF. So far in 2 years, it has been downloaded over 700,000 times. And you see a lot of the contribution and adopted by a lot of the end users. So on the right-hand side of the diagram, as you can see, KubeArmor here leverage the eBPF for the application model or application behavior, understand the process, the files, the network, and leverage the eBPF for the authentication cover, and also to apply the zero trust list permissive control. Now, how to enforcement the security controls or security policies, you leverage the AppArmor SELinux or BPF-LSM. So a couple of examples here, you can secure your secrets. So that's part of the secrets hardening, or it can be used for the inline mitigation or remediation, and also for the system hardening. So where you can deploy KubeArmor. So first of all, it can be deployed to Kubernetes as a daemon set, or can be deployed to the VM or other containers or Kube Vault as a system daemon. So what's unique from a KubeArmor? So on the left-hand side, you can see KubeArmor leverages eBPF extended Berkeley packet filter for the observability to identify the application behavior, which process we should be allowed, which files we should be allowed to access, which network should be allowed. And based on this understanding, and with the policy enforcement, LSM module is here, can be used to use any one of the ways, AppArmor, BPF-LSM, or SELinux. You apply the allow list here. Essentially, it will block the rest of the access once you turn on the zero trust model. So it can be leveraged to effectively to block the hacking activities, could be malicious tools, or could be ransomware attack, could be someone trying to taking over to copy your secrets, or maybe service account tokens. So that's what they call inline prevention. So in my opinion, this is a much better approach. So let's see what other vendors do. So the vendor A here, they also use eBPF. Yeah, it is actually commonly used by all the security vendors and the observability vendors. What's going to happen from a vendor A here is they will use eBPF to monitor, to detect if there is any malicious activities or any hacking activities, or maybe unwanted process is running. So once they detect the problems, they will kill the process from the user space. So it's good, finally you find the problems, you kill the process from the user space. But from the time you detect the problems until you kill the process, the damage probably already happened. So your secrets may be already exposed. Your service account token could be already taken by someone. And maybe your system already started encrypted by the ransomware. So it's too late to kill the process after you detect the problems. So what other vendor did is similar. So vendor B and vendor C might be slightly better because they can take the actions from the kernel space to stop the containers, or maybe send the BPF to send a signal to kill the process from the kernel, which is slightly better than vendor A, but still the same problems. So from the time you detect the problems until you kill the process, there is a gap. So that becomes, well, it is still good to block the further damage, but compared to KubeArmor is much better because from the beginning, you can block such hacking activities happening. Because once you apply the zero trust policy here, you're not allowed to run any other abnormal activities. You're not able to take any actions. So shortly in the live demo, I will show you how you can block such activities happening. So first of all, what's supported? Just to summarize again, the Kubernetes workload can be supported. It can be deployed to Kubernetes cluster as a daemon set, or can be deployed to other containerized application as systemd mode, or can be deployed to VMs or bare metal machine as a systemd mode as well. So in terms of Kubernetes cluster support, you can see literally any one of the Kubernetes listed here can be supported. So yeah, I'm not going to go through all the list. You can see GK is here, AKS is here, IBM IKS, OK is here, EKS is here. Literally any one of the Kubernetes are supported. What about the Linux distribution? So again, variety of the different version of the Linux system also supported. On the right-hand side, you can see, if you want to check the full support metrics, here is a link. So I love Kubernetes. Let me use Kubernetes as an example to show you the architecture. So you're going to cluster running here. KubeArmor deployed here as a daemon set. You will see a couple pods running from the user space. And eBPF is here to be used to monitor, to modeling the application behavior. So how to apply the policy to the Kubernetes cluster. So you basically create the YAML file. You just use the standard kube control, apply the YAML file, and it will pass to the kernel Linux security module, and it will be implemented via AppArmor, SELinux, or BPF-LSM, depends on which system, Linux system you're using. And then by doing this, it will be applied to the system to only allow certain activities happening. Could be you only want to allow certain files to be accessed, only certain network ports, or maybe certain process can be accessed. KubeArmor also provide the command line tool if you want to try. And once you detect there is any malicious activities or any alerts or policy violation, it can be sent to the alerts via the standard output, or can be integrated with third-party SIEM tools. Let's see how to integrate with third-party. So it leverages the KubeArmor relay server to extend the outputs. The KubeArmor relay server will be deployed to the Kubernetes cluster across each of the nodes. By the way, it deployed the default with the KubeArmor. It does two jobs. So first of all, collect all the messages, logs, alerts, and then allow other logging system to collect through the service. Okay, so how to stream the KubeArmor telemetry to theme tools? So first of all, let's see what type of the telemetry events generated by KubeArmor. So number one, the alerts when the policy is violated. So number two, the logs when the policy executes a sys call or any other actions like a process, launched, or maybe file access, maybe network socket connect, create, or open, accept, etc. Or maybe just the internal KubeArmor demo messages. So how to stream to the SIEM tools? There are two ways. One is via the KubeArmor relay standard out. The second way is via the adapter. So the first example here is we're going to use the KubeArmor relay, configure the standard output to send to Azure Sentinel as an example. Or you can create an adapter to connect to Azure Sentinel. But it's not restricted, limited to Azure Sentinel. It can be integrated with Splunk, Grafana, etc. So that's just an example how you can integrate with third-party SIEM tools for the alerts, for the notifications, etc. So I guess it's time to see a live demo. So I'm going to jump to AWS Cloud as an example. As you can see, I actually just launched AWS EKS cluster moments ago. Let's see. So I just created the cluster 14 minutes ago. It is running 1.29. Let's monitor, let's watch the pod status while we're going to deploy KubeArmor. So how to deploy? So I already, if you don't have a Kubernetes cluster up running, so I use EKS as an example. You literally just run one command, eks-deploy.sh. So in a few minutes, you will have a up running EKS cluster. So we can use that one as a demonstration. So I already have an EKS cluster up running. So the next step is we're going to just run one command, karmor-deploy.sh. Then we will install KubeArmor to the running EKS cluster. So once you've done your testing, if you want to clean up, that's the second command, karmor-destroy.sh, to clean up the whole environment. So come back to the console here. So I want to show you quickly where are the scripts, where are the commands, all the YAML files. If you go to my GitHub page, you can see EKS Casa. I use the EKS as an example. Technically, if you want, you can try Google, you can try Amazon, Microsoft AKS. So I use the EKS as an example. all of the commands are included here. The eks-deploy, the KubeArmor deploy, how to deploy KubeArmor. You click this command, you can see how to install KubeArmor on EKS cluster. Yeah, just a couple of commands, but I love automation. So I just put all of these commands to this KubeArmor-deploy. So I'm going to run this command to install KubeArmor first, and then I will jump to the test guide to show you step by step to run a couple of test cases. So from the terminal here, I'm going to run KubeArmor deploy. So press enter. As you can see from the screen, I split the two terminals here. On the right-hand side, you can see KubeArmor created the namespace, and the KubeArmor operator is already up running. And shortly, I also deployed a sample Nginx application. So we're going to use this one as an example to test how we are going to secure via KubeArmor. So shortly, you can also see KubeArmor relay server will be running, and then KubeArmor control. There is a separate port, and there is a job called KubeArmor snitch, and the KubeArmor running as a daemon sets. That's the KubeArmor port, BPF-containerd. So shortly, it will be up running, and then we can move to the next step. So the first test case I'm going to show you here is I'm running the Nginx web application. I don't want anyone to run a package management tools, which is pretty risky. Potentially, a hacker might be leverage the package management tool to install some more hacking tools. So I'm going to create the KubeArmor policy here, and then apply to this particular namespace, apply to this particular containers, and which path. So I'm going to block the package management tool listed here. The action is block. So how to apply the policy? You guys are familiar to Kubernetes. You just run kubectl, apply the YAML file, and then you can run a couple of tests. So you can see if you can still run the package management tool. So you can verify, use this command KubeArmor logs to see if there is any a policy violation. So let me come back to the console. I'm going to watch the logs first. So KubeArmor logs. So in the second terminal here, I'm going to watch to see if there is any alerts, any policy violation. In the meantime, I'm going to run the first test case. So first of all, I'm going to get the pod name, paste the command here. I got the pod name. Then I'm going to apply the policy. Before I apply the policy, let me see if I can actually right now, if I can run the package management tool, press enter. So it looks like I can run the package management tool right now. So now I'm going to apply the policy. After apply the policy, let's try again to see if we can still run the package management tool. So watch the right-hand side of the terminal. So once I kick off the command, you can see the alerts actually generated. You can see the action blocked. So we blocked the APT, that's the package management tools. The permission denied message also showing from the log. From the command line, you can also see the APT command, the permission denied. So that basically covers the first test case, how to deny execution of any particular command. So I use package management, the APT as an example. Technically, you can customize the YAML file to apply to block any other process running. Okay, so the second test case I'm going to show you here is, so we are going to deny access to the service account token. Here is the policy. So we are going to taking the action block one, block the service account token access, apply to the namespace, match this label, So first of all, let's try to see if we can access the service account token. And then we will apply the policy. And finally, we will try to access this to see if we can access the service account token again. So hopefully you will see the forbidden messages like the screen you can see. So let me go to the terminal. So I'm going to resume the terminal. Now, what I'm going to do here is, so we're now at the test case here. So we're going to run this command to execute to the port. And then we're going to see if we can access the service account token. Yeah, looks like it works. It returned successfully. We're able to access the service account token now. Now, if we're going to, first of all, let's execute from the port, and we're going to apply the policy. So now we just apply the block service account token access. If we're going to try the same command again, let's see. So first of all, execute to the port, and then run the same curl command. Yeah, you see the error messages here. Status failed and forbidden. And on the right-hand side, you can see, so the action is blocked to access the service account token. Okay, that means the KubeArmor is working effectively to deny the access to the service account token. So that's the second test case. So the next one I'm going to show you is in some situation, you probably just want to audit the access to the certain folders or paths. So in this case, we can create another similar YAML file, apply to this namespace, match this label, apply to /etc nginx. That's the one I want to audit the access. Action is audit. So before you apply the policy, make sure you turn on the visibility, because by default, the file visibility wasn't turned on. Okay, so we run this command to turn on the visibility for the files. And then we apply the policy, followed by we just try to read the file from that particular folder to see if there is any audit logs are generated. So come back to the console. So first of all, let me exit from the port. And now I'm going to apply the policy. So first of all, let's turn on the file visibility. So I run this command, I turned on the file visibility, and now I'm going to apply the audit policy. So once you apply it, if we're going to execute to the port, try to read the file inside of that particular folder, let's say, yeah, we do access to read the first few lines of the nginx configure file. On the right-hand side, you might notice we just generated the audit log. So which files we access /etc/nginx/nginx.conf file, and it's an audit action. The result is passed. Okay, that basically covers the third test case, how you can use KubeArmor to audit the access to certain folders or paths. The next one, that's my favorite one. So how to turn on the zero trust. How to allow only Nginx to execute and deny the rest. So pretty simple. Similarly, you create a YAML file, apply to this namespace, apply to this particular application. So apply to which folders and which paths. So we're going to allow. So by list the files processed here with the action allow, literally, it will only allow the allowed list here, and deny the rest of the access. That's the what we call the zero trust architecture. So the zero trust model. So you basically just apply the YAML file, and then you can turn on the zero trust model. By default, KubeArmor is running in audit mode. With this command here, we're going to turn on zero trust model. That will be default deny and only allow the certain process listed here. And then you can try to run some command. Let's say I want to run the password command to change the password. You will see the error message, a permission denied. And finally, we can verify if my Nginx web application are still up running. So come back to the terminal here. What I'm going to do here is we are going to apply the policy first. And then if you want to verify the policy, you just run kubectl, list all the KubeArmor security policies from the particular namespace. You can see so far we created 4 KubeArmor policies. It's all listed here. And then, yeah, but if you want to verify what exactly inside of that particular policy, you just do kubectl get KubeArmor security policy, this particular namespace, the Nginx, and output as a YAML file. You can see that's exactly the one we created. So you can see we're going to allow only these 2 paths. Okay, so action is allowed. So now let's try it out. We're going to turn on the zero trust mode or turn on the default deny mode. By running this command, we're going to change the mode from audit to default deny. So now keep watch of the right terminal, and we're going to try to see if we can run a few commands. If I'm going to run the command password, no, I copied it to the wrong window. So copy here, you can see the alerts has been generated. So action block, permission denied, the error message is listed here, the process here. So you can see from the command line, you run this password command, you got the error message, permission denied. So if you want to try again, yeah, you can run a few commands. So let me try the list command. So you might see the same error message. Yeah, permission denied. You're not allowed to run any process except the one we specified, which is the Nginx web application. So finally, let's verify if my Nginx web application are still, up running. So I'm going to run this command here. So with the port forwarding, I should be able to verify if my Nginx web application are still running. On the right-hand side, I run the curl command. So as you can see, the Nginx web application is successfully installed and still running okay. That basically cover the 4 typical use cases listed here. How to apply the zero trust policy, how to apply the audit policy, how to deny certain process running, how to auditing the file access, etc. So if you want to learn more, yeah, feel free to join me to learn together. I created the automation, and all of my test cases also recorded here from my GitHub repository. Feel free to make a pull request. If you find some new use case, if you learn something new, please add. So personally, I feel like, we only learned just the tip of the iceberg. I know KubeArmor does have a lot of other use cases. It could be you want to do the secrets management. You want to secure the secrets. Could be you want to secure your Jupyter notebook or Jupyter lab. So it is commonly used by the data professionals. And it could be data analysts, data scientists, etc. The Jupyter notebook, it's not secure. KubeArmor can help you secure the Jupyter notebook. I might record a separate video to talk about some other use cases. So there is another one I want to highlight is KubeArmor can be used to hardening the system based on the compliance framework like a CIS benchmark, NIST compliance framework, or STIGS, etc. So feel free to explore a little bit more. Here is a KubeArmor official web page. Here is a KubeArmor GitHub repository. Feel free to join the most active Kubernetes user group. Feel free to join the most active Kubernetes discussion group. That's pretty much all I want to cover for today. If you do have any questions, feel free to follow me via any one of the links. And if you do find this is useful to you, please like the video and reshare the video with your friends. Thank you so much for watching. I hope you enjoy your day.